out 20 grams of sodium hydroxide pellets. If sodium is 23, oxygen is 16, and hydrogen is 1, what is the mole of sodium hydroxide? I read again. An undergraduate weighed out 20 grams of sodium hydroxide pellets. If sodium is 23, oxygen is 16, and hydrogen is 1, what is the mole of this sodium hydroxide? We are asked to look for the mole. So the formula for mole, when we are given the mass, because we are given the mass of sodium hydroxide, mass is given to be, he said 20 grams. So mole equals to mass over molar mass. That is the formula to look for mole if you are given the mass and molar mass. So now we are not given the mass and the molar mass. We are not given per se. So we are going to calculate the molar mass. To calculate the molar mass equal to, they said it is sodium hydroxide. You are going to write the formula for sodium hydroxide. That is Na caustic soda. NaOH. So now, what is the mass number of Na, which is sodium? It is given in the question if you don't know it before. It is given. And what's talking about? Now, I want to confirm if people are really getting what I want to do. Maybe the question I'm doing. Hello, no one?
23.
What is the mass of?
We are with you.
23.
Don't unmute your mic, please. Just let's write them out. Anything we say, or unless you have to say something that's quite long. So sodium is 23. So I'm going to write 23. I want to calculate the molar mass of sodium hydroxide. Plus oxygen is 16. That's the mass number of oxygen. Plus mass number of hydrogen, 1. So by adding this one together, 23 plus 16 plus 1 is going to give us 40. So now we have the mass to be 40, to be 20 grams, and molar mass to be 40 grams per mole. That is the unit of molar mass, grams per mole. Grams per mole. So number of mole equals to mass over molar mass. What is the mass gotten? 20 over what is the molar mass? 40. So this is 20 over 40. You guys, you should have your calculator with you. When you do the mass, you are going to get 0.5 mole. That is the answer. That's what you'll be writing in the space provided. Any question on this before we move to the next question? Kindly ask. All your questions are welcome.
The answer I'm saying here is 0.25 mole.
My brother, they chose that 0.25. Don't you believe they might be wrong? This is what you are going to do. This is the only method. Not all their things are right too. You understand, sir? So I'm assuring you that the formula
Yeah,
for
sure, I understand.
molar equals to mass over molar mass. And we are given the mass number to be 20.
Of course,
and the
of
molar
course. Of course.
So 20 divided by 40 is 0.5 moles. So that is the answer.
0.5,
Okay, Evening. When I was doing the CVT practice, I tried 0.5 mole. Then I noticed the answer we give matters. So I don't know, should we add the E at the end, that's MOLE or MOL? Hello?
Sorry, my network did. Okay, Mr. K, thank you for the contribution. Every one of us that's asking about 0.25 and 0.5 now, there is an assumption. Let me say that there is a conclusion made now by Mr. K. He said, not a question, but observation. The 0.25 mole is due to copy and paste from the course material, which uses 10 grams instead of the 20 grams. So the course material used 10 grams. So they now thought the questions are the same. So they just pasted the answer of that thing into it immediately. So that's the answer to you guys' question. Thank you. That's exactly what's there. So thank you, Mr. K. That's what they always do, to be sincere. Okay, now I think I want to assume there is no question on the first thing. The number of mole equals to mass over molar mass. You are given your mass. To calculate the molar mass again, you are going to write the formula out. So if it is caustic soda, this is sodium hydroxide. You are going to write sodium 23. If you don't know these things, you might be given if you are lucky. If you are not lucky, you just have to go and know mass numbers. So caustic sodium is 23. Huh? Prodigy, I think you are going to do someone a favor inside the group. Oh. Okay, no. This one is not talking about our stuff. It's another thing. Okay, so 0.23 is the mass number of sodium plus oxygen is 16 and hydrogen is 1. So we got 40 grams per mole overall. The unit of molar mass is grams per mole. So now I have mass number, that is mass over, that is 20 over molar mass, which is 40. So 20 divided by 40 gives 0.5 moles. So now we have question 2. What's the question?
Sorry, it's a mistake, sir.
Okay. So now, finding please. We won't be able to cover out all the. So the second question is the base unit of the measured liquid body.
Sorry, but your voice actually.
You guys should mute your mic. Oh my God. Beatrice, mute your mic.
Okay, sir.
Please. Thank you. So now, the second question. Okay, Chioma, anything? Any question? Please, if you don't have question, don't unmute your mic unnecessarily. You can just signify by raising a hand. We don't have much time to waste. This is about 120 questions. I don't know if we are going to finish it with this way you guys are doing. Please. So we have the base unit of a measured liquid called volume is what? So this question now, their question, it depends on how smart you are and how lucky you are. The base unit of a measured liquid, some people will go and choose centimeter cube. Some people will choose decimeter cube. So the answer to this question is, I don't know, some of you have the answer with you here now, but the one I have with me actually doesn't have the answer. I'm reading it from my system. So it doesn't have the answer with it. So as for me, what I'm going to choose here is liter. Any other person that antagonizes that? The base unit of a measured liquid called volume is, I believe it is liter. So any other thing?
You want use cubic meter. Cubic meter.
Cubic meter. That is 2 power 3. Okay, thank you. Another one. The answer in noun system is cubic meter. All right, thank you very much then. So they are using cubic meter from SI units. Thank you. I've also learned from that. I will agree it is cubic meter. Okay. So now the next one is the base unit of a measured or weighed solid material in chemistry is. So I think this base unit they are talking about now is the SI unit, the System International Unit. The base unit of a measured or weighed solid material in chemistry is. So I won't let us make it so interactive that we'll be asking ourselves this. So this one is kilograms. The base unit of a measured or weighed solid material in chemistry is kilograms. So if you don't agree with me in some places, kindly signify before we go far. And if you don't understand anything, kindly simplify, please. Please. Are we together?
We are together.
Thank you. So now the next question is.
No, yeah, just talk on
Okay, Miss Juliet.
I want to know, is it kilogram or grams?
It is kilogram, that is the base unit. We're talking about the SI unit. It is kilograms.
All right. Thank you, sir.
Kilograms. So gram is just a factor of kilogram. That's 1/1000 kilogram. Miss Chioma.
Yes, please. The course material, which question?
This one now we are doing. This one. Are you
It's
inside
different from
one
what
group?
the
The
thing is different
material.
from what you're doing. The one
What
you
you have
sent to
with
the
you.
group just
We sent another one to the group. Immediately we started this meeting. We sent another one to the group. You can take a good look at it. The last document sent to the group is what we sent.
okay.
Take a good look at it. Check it. The last document. It is physics and chemistry 1911. They wrote the one multiple times. 1111111 dot PDF or something. So that's what we're using here. So question 4 says the technique of separation employed to purify an organic solid that may be contaminated by impurities is called. Anyone to give us the answer here? So let me see if it's going to concur with my
Recrystallization.
crystallization. All right, I also have that in mind. So we concur with that. Any other person that antagonize that? Is there anyone that doesn't believe it?
Please, can you read the question again? Sorry.
Okay, the technique of separation. The technique of separation employed to purify an organic solid that may be contaminated by impurities is what? So it is recrystallization. So if you don't agree with that, kindly come out with your explanation, please. So that's why we are here, please. And we will be convinced if you're right. Okay, we should keep going. They said the technique employed for separation of colors is called the technique employed for separation of colors is called
Chromatography.
chromatography. So we spell it as CHROMATOGRAPHY. So that's chromatography. Thank you. Okay, we're still moving to question 6. Let's see if we can cover some few things before we finish this class. The separation technique employed to separate mixtures of two or more liquids with slightly different boiling point is called. So there's a difference in the boiling point. That is what accounts for the distinction between them. The difference in the boiling point, like alcohol and water. So they are miscible, but they are different in the sense of their boiling point. So they have different boiling point. So the answer is going to be
Please, can you help me send the past question on the screen? Because I'm not able to access that link, please.
as for me, I don't think I can do. I'm not using the system with me now. I think one person can do it. That should be.
We have done that several. I just did that again now.
Please, you can redo because of people like this, and moreover, they can listen very well to us. And even if you can add that to the group, please, just don't let her be left out, please. This is why we are doing the class. May God help every one of us. So the question 7, okay, it should be 6. And someone mentioned fractional distillation now. What about ordinary distillation? Is that not possible to separate them?
No, I don't think so, because if you look at the definition of fractional distillation, to me,
Okay,
starting
please
from
speak out.
starting from my secondary school, what I used to identify it is anytime I hear something like two or more, this thing, what they call it, like when we talk about the water and alcohol stuff, I used to know that it's fractional distillation. So that one, I don't know how to explain it. But with the definition, we will know that ordinary distillation cannot do this. Because when we
Okay,
talk about the distillation, I think distillation definition is a separation of mixture liquid of a different volatile or boiling point. I think
I love
so.
you. Yeah, you are correct. So I wanted to clarify the point myself before, but that's exactly the way she brought it. So that's exactly the difference between the both of them. So the fractional distillation is used for separating the crude oil fractions, petrol from gas, petrol from gas, from diesel, from kerosene, stuff like that. So thank you very much, Ms. Aminat. Thank you. You are loaded. Okay. The next one is question 7. The condensate collected during the vaporization is called the condensate collected during the vaporization is called anyone? The condensate.
Distillate.
The condensate collected during the vaporization of liquid is called distillate. Does anyone antagonize that? Anyone that doesn't agree with that? Is there anyone that doesn't agree with that?
It is called the distillate.
Anyone? Okay. Thank you. Hope we are moving together like this, yeah? Because people are not antagonizing. Like I expect people to be saying, I don't agree, I agree, I don't agree. Okay, if that's the case, we keep moving. But that's actually right. So an apparatus that can be used to remove traces of water from the substances. So I expect people to have different answers for this. But thank you, Mr. Olabi, thank you. Thank you. Another person. Okay. Two people use desiccator now. What do you think? Is desiccator not part of the drying agent? Why can't I say drying agent? An apparatus used for removing water from the substance, traces of water from the substance is known as a drying agent. However, if I do that, it's called a drying agent. Must I write desiccator? Is there anyone that's going to talk about that now? Is it not drying agent? Must it be desiccator? Anyone? So that should be a work for every one of us. I'll also work on it. Do we have different types of drying agents, or do we have just the desiccator as the drying agent? If it is okay, then desiccator will be the right answer. Or if it is more than desiccator, I will implore you to just write drying agent. Drying agent. Did we all get that? Because I think in cases like this, you really want to find them out. Ms. Ugumba, I would like okay. The process by which traces of water is removed by treating the liquid with suitable drying agents is called the process by which traces of water is removed. Okay, thank you, Mr. Samuel. On the noun system, the answer is desiccator. Okay, as I'm even reading the second question now, the next question to it, I'm trying to believe it is desiccator. I'm going to explain my points now. The question says the process by which traces of water is removed by treating the liquid with suitable drying agent is called. So definitely, drying agent should not be an apparatus. It should just be a chemical, like the silica gel, all other drying agents like the ammonia, calcium oxide. So drying agents are just chemicals, while desiccator is the apparatus. So now go back to question 8 and believe it is desiccator. Ms. Amina and Mr. Olabi are absolutely right. Is that? So thank you. The process by which traces of water is removed by treating the water with suitable drying agents is called dehydration. It's called dehydration.
Please excuse me. Which PDF are we using?
Okay, the last PDF sent to the group. Go and check it. The last PDF sent to the group.
Okay.
Yes.
Joy, I've entered you on the group.
I cannot be watching the PDF and at the same time be doing this with.
We are not solving anything. Let me off my video. Oh, yeah. Be with your PDF. Once we get to question, you can leave your work and come to this. Mr. Andrew is there. He's going to help us type if it comes to question. He's a good man.
No, there's no issue. We are fine like this.
Okay. So now let's keep moving. Question 9. We said the process by which traces of water is removed by treating the liquid with suitable drying agent is called dehydration. That means you want to remove the water. So now the separation, that's question 10, is the separation technique employed to purify an organic compound or to separate mixtures of liquids or boiling point. It's called, Miss Amina, I don't want you to say anything here. I expect people to have understood the answer to this question. Distillation. Thank you, Mr. Ulabi. That is the answer. So, Mr. Ulabi, I think you're writing the thing out. You know it. So I think you should write the number before writing it. It will help some people when they come in. You know it is question number 10. You should just write number 10. Distillation. Help. Thank you, sir. Okay. A separation technique used to isolate a desired solid from a solid liquid mixture or for freeing a desired liquid of solid impurities is called, okay, number 11, a separation technique.
Sorry, I have a question.
Okay.
I missed your explanation before. But please, what's the difference between fractional distillation and regular distillation again, please?
The ordinary distillation is based on the difference in two things. How volatile are they? That's the first thing. And the second one is, what's their boiling point? So, but as for the fractions of crude oil and the ones we are using fractional distillation for, like we want to get air to liquefaction of air and fractional distillation of liquefied air, that one depends solely on the boiling point. That's the main difference between the both of them. Distillation works with volatilities. That's how volatile is it, or it is. Do you understand? So that if you encounter something like this now, you should know that the one that comes with volatility is distillation. Why the one that is just ordinary and might even have some complex stuff with it, that one is for the fractional distillation.
Thank you. Understood.
My pleasure. Okay. The separation technique employed to purify this. Okay, number 11. Right, number 11. A separation technique that is used to isolate a desired solid from a solid liquid mixture or freeing a desired liquid of solid impurities is called, that is, we have a solid and liquid together. We want to remove the solid from it, or we want to remove liquid from solid and liquid when there are impurities with it. So the method is called what? Anyone?
Filtration.
Anyone? Auntie Amina, I don't say anything.
Filtration.
Thank you, Miss Duebi, Mr. Laika. So thank you. So it might actually be used to get the solid out, and it might be used to get if the solid are impurities, to get the liquid out too. So the reagents that will not make any significant contribution to the theoretical unit. The reagents, I'm ready to learn from you guys. I don't need the answer to this one. The reagents that will not make any significant contribution to the theoretical yield is 12 limiting reagents. I guess. Okay. Any other person with the guess? Amina.
Yeah, I think a limiting reagent.
Limiting reagent. That's number 12. Limiting reagent. Limiting reagent. Okay. The reagent that will not make any significant contribution from the quantity. Thank you. Limiting reagent. Okay. The next one is question 13. A high percentage yield implies that. What does that mean? You know, all these things are in a few words. I don't even have options with you. So it's not easy to assume from my own side. A high percentage yield implies, don't raise hand again, Abi. Another person, please. A high percentage yield means what? Successful reaction. Okay, that's very good. Prodigy never reach out.
I think the statement is not even complete.
Sorry, what did you
What do
say?
you say? Miss John. No, I'm like,
Are you asking me?
hmm?
Are you asking me?
Yeah, you said something. What did you say?
Okay, I said maybe the statement is not complete.
No, it's
Is
complete.
it complete?
It's complete. It's
Eh,
complete. You get the answer now. I'm very sure we have people here that can answer the question. I think I have the answer to it to myself. So, Prodigy, I said, okay, you haven't gotten home. Your place is making noise today. It doesn't happen that way. All right.
I'm home
So,
now. I'm at home.
hmm?
I'm at home.
It's not silent today. That's what I mean. Like it's always meaningful. Like my place like this. Okay. Yeah, who is writing this for us? A high percentage yield means what? What does it imply? Miss Aminat. You raised your hand before. Okay, I think I've seen someone wrote something.
Oh, sorry. Sorry, I'm so
Yeah, it
The answer,
implies successful reaction.
thank you very much. Miss Joy, did you hear that?
yes.
So now we still
Sir,
move and
please,
we
can you
a
explain
successful
why it has a
action.
successful reaction?
yeah, they said a high percentage yield implies a successful reaction. What they are trying to say here is that when you do a particular experiment and you have this result, your result maybe is close to 100%. That means you've made some assumptions before. Now, what your experiment yields is 100%. That means what's it called? The experiment is absolutely successful. I think this is part of the terms given in the. If I'm going to explain it, I won't be using that term to be said. It's given in the course material. I think the term is given in the course material as successful experimental reaction. So that's if you are getting a high percentage, that is what you are getting is not close to what you assume, then the reaction or the experiment has not been successful. That's what it means. Yeah.
Can I read
Yeah.
something from here?
Okay. Do that.
Okay, a high percentage yield implies that a large proportion of the reactant was successfully converted into the desired product during a chemical reaction.
Absolutely. We are saying the same thing. Do you believe?
Yes.
The amount of the reactants now converted into the product. This has been the assumption or the prediction before the chemical reaction takes place. So after it happens that way, maybe we've gotten a particular amount that is very high. So that means high amount of the reactant converted to product. Then it makes our assumption right. This thing, if it comes in a reverse manner, definitely we are going to have a low percentage yield. And we say it's not favorable with our prediction. That's exactly the way it is. So the both of us are saying the same thing. I'm only explaining my own thing. I'm only explaining my own things like with my brain. I'm using my brain to explain it. I'm thinking maybe the way I can express myself better. That's the only way. Okay. Question 14 says the reagent with a stoichiometric amount, that is in moles. A reagent with a stoichiometric, let's always know that now input only one answer to the assistant. Thank you. That is it. Thank you, Mr. Samuel. So let us note that too. That means we have to read the course material very well. That's why I'm actually concurring with what people are saying here. People that actually get the thing by studying the past question. So I actually agree with them. If I have anything that is not going with them, I will say it. But once I get this is I have to move with it. So now We have this one now. The reagent that is stoichiometric with a stoichiometric amount that limits the amount of desired product formed is called what? The reagent with a stoichiometric amount in moles that limits the amount of desired product in moles formed is called what? Anybody?
Limiting reagents.
Okay. Well, it's limiting since morning now. Limiting reagents. Okay, wait. I think there was a question like that too. There's a question an apparatus that is used to. Okay, reagent that will not make any significant contribution to the theoretical yield. So it's rate with a stoichiometric amount that limits. Okay, that limits. I don't believe the vocabulary will just go like that now. As simple as that. Limiting that limits the amount of desired product form is called. Okay, everyone. Hope I'm not the only one learning from this. Hope we are all learning from it, please. I want us to signify. Hope we are all learning from this. Just write. I want to believe we are all learning from this. Okay. Thank you. I don't see two people. If others not reply, I don't see two people. Okay. The actual yield of products in grams or in moles expressed as a percentage of the theoretical yield is called what? The actual yield in products expressed as a percentage of the theoretical yield is called what?
Percentage yield.
Perfect. So they will say actual yield, that they will say the yield, the actual yield over theoretical yield multiplied by 100. We'll get the percentage yield. So this is the thing here now. Thank you. So number 16, the number of protons or electrons in the atom of an element is equal to the dash of the element. The number of protons or electrons to the atomic number. So now the atomic number of an element is equal to the proton number in the nucleus of that element. If the atom is oxygen, it has the atomic number of 8. Definitely it has the proton number of proton, 8 as 8, and it has 8 electrons. The same number of protons and electrons will be in the same atom. If it is 8 in the nucleus, 8 will be revolving around the nucleus. Okay, Ms. Aminat. Speak out. Ms. Aminat, speak out. Raise your hand.
Atomic number.
Sure. Someone has said it. I think your service is lacking you behind. Someone has said it. Thank you.
Yes. Okay.
So I'm actually just explaining it. Someone has said it already. So the atomic number is the same as the number of proton, and it is the same as the number of electron, not the same with the number of neutrons. So depending on the atom, there's some atom that have the same number of proton and neutron. So now the next one is question number 17. Calculate the hydroxide ion concentration. The hydroxide ion concentration, that is the hydroxyl ion concentration of an aqueous solution of pH 11. Of an aqueous solution of pH 11. Calculate the hydroxyl ion of an aqueous solution of pH 11. Okay, so what we're going to use here is, let me say one formula we all know. I'll do this one, the next one someone else will do it for us. Let's do this one for us now. Don't let us waste our time. Hydroxyl ion of an aqueous solution with pH 11. You know our pH equals the this one, that is the hydrogen ion concentration, and the what's it? pH equals hydrogen ion concentration, that's minus log hydrogen ion concentration. We all know what this one too is. So now we should just take our pH equals to 11 equals hydrogen ion concentration, I think plus, what's this one? 11. This one is going to be equal to 14. We know the 14 is the scale, is the whole scale. So 14 equals to hydrogen ion concentration, and
You are not showing your screen.
I'm already trying to show it all.
Okay.
pH equals hydrogen ion concentration. I'm trying to recollect the formula. It is this. pH equals this. So OH minus H plus equals 14, if I'm not wrong with myself. Okay. I have a textbook here. Let me try to confirm myself. I'm not the only one working. I shouldn't risk people's work. Okay. So I have it this way. pH, okay, the both of them, that's what I want to confirm. So OH minus, and that is hydroxyl ion, and the hydrogen ion gives 10 raised to power minus 14. What is it? 1 times 10 raised to power minus 14. Okay, so that's 1 times 10 raised to power minus 14. The hydroxyl ion now is it 10 raised to power 11, and hydrogen ion equals 1 times 10 raised to power minus 14. So hydrogen ion is going to be 1 times 10 raised to power minus 14 divided by 10 raised to power minus 11. That's 10 raised to power minus 25. Does that concur with it? Are there some people with the options? What will be the options there? If we can work towards it first. The option, anyone? It should be 3. C.
Yeah, it should be 1 times 10 raised to power minus 3.
1 times 10
raised to power.
This is
power minus 3.
We are looking for pH. Okay, we are looking for hydrogen concentration.
Yeah, I think.
C.
Okay.
This is what pH plus POH. This is the pH. Let's do this one finish first. pH plus POH.
So someone teach me how 14. To by mistakenly
what she say? Well,
power of
hydrogen plus power of hydroxyl ion, and POH is going to give us this. So now pH is given to be for 11, right? An aqueous solution with pH 11. So pH is 11 plus POH equals to 14. So we can get our POH now. POH, that is the power of the hydroxyl ion, equals 14 minus 11. So it's going to give us 3. POH equals to 3. So that's 3. This is the power of hydroxyl ion we calculated. We are asked to look for concentration of hydroxyl ion itself. Concentration of hydroxyl ion itself. And it's just a mole now. It's not like 2 moles or something. So what we need now is just that. Concentration of the hydroxyl ion is going to be the 1. There is a way we write it, minus log. We read the minus log to hydroxyl ion. Okay, so minus log. Okay, minus, this is hydroxyl ion. So 10 raised to power minus 3 will be the logic there. So I'll have 1 times 10 raised to power minus 3. So, but this POH3 is what implies that I'm going to get 3. 1 times 10 raised to power minus 3. So that's what I mean from this. Any question? Any question?
Sorry, yeah, I have a question.
What is it? Hi, what's this? Okay, again, this is what I'm writing. I said the hydrogen, power of hydrogen, the pH.
Sorry, you might be wondering why he asked. You are just saying what you are solving since.
I'm the only one saying it.
Yes.
I don't know now. That's no day now. Okay, take a good look now. Yeah, see. No, we only will say them again. So pH plus POH is going to give us 14 because the acid and the base, they make up the pH scale. So now pH is given to be 11 and the POH is not given. We are looking for the POH first. So POH is equal plus pH is equal to 14. So now making POH the subject. POH equals to 14 minus 11. That's from this plus 11 here. So POH equals to 3. That is the POH, power of the hydroxyl ion, equals to 3. So now, is this 3 that will be the power? This 3 that we have as the POH is going to be the power when it is, when they say pH is the negative log leading to the hydrogen ion concentration.
Please, we are not seeing it again. We are not seeing it again.
I don't know. I'm seeing it myself. I think it's the network.
I can see it. I can see it clearly.
Yeah, they see
It's
What
not
you should
showing
do is
again.
that you should click on his video and make it full screen so that it will be only his video that you'll be seeing.
It's on full screen already. Okay, I'm seeing it.
I don't know about that one. So, is there anyone that's not saying it now again?
I'm seeing it. Guy, please, how do you come about that 14? 14, that 14 equals to pH plus POH is equals to 14. How do you get that 14?
Law. This is a law.
That's the formula.
That's the law.
It's a
The
law.
law is that pH plus POH will always give you 14. The hydrogen scale and the hydrogen scale will always give you 14 in the pH. That's pH scale. You have 0 to 7 for hydrogen and
Yes.
7 to 14 for base. So we always have the law. Now we are given the pH to be 11. Thank you. It is constant like that. Though it's not a constant, but it is constant. It is uniform for every form of it. It is constant. That's how they use it. Thank you for getting that. So 11, which is the pH, plus POH equals 14. So POH equals to 14 minus 11. So my POH equals to 3. So there's a logic here. The hydroxyl ion concentration is going to be, when I say the thing is going to be minus logarithm of hydrogen ion concentration. Yeah, negative. What's it? You just join. Continue. Correct now. So minus log of hydrogen ion concentration. So if it is hydroxyl to be minus log of hydrogen ion concentration. But the simple thing here is that since you have this is 3 as your power of hydroxyl ion, just know that, and it is just a mole. They did not give us that maybe 2 moles of this thing. So just know that you have 10 to the power of minus 3 as your hydroxyl ion concentration. This is the hydroxyl ion concentration. That's 10 to the power minus 3 moles per liter or moles per dmq. I think Prodigy gave that as an option there. It's one of the options there, right?
Please, I don't still understand how we got that 10.
This 10 here. See, what is pH? They write pH as minus log hydrogen ion concentration. Abi, do you know that first? Do you know this one before? So, hydrogen ion concentration and hydroxyl ion concentration is going to give you 1 times 10 raised to Yeah.
Ali, think I think what we should focus on is now this one that we're given 11, so it should be 11. So automatically that will be 10 raised to power minus 14 plus 11 will give us the 10 raised to power minus 3. We are not given as minus 11, it is plus 11.
You are not given as minus 11,
The
but
major,
that's the pH. Do you know that the pH equals to minus log
the
hydrogen atom concentration? This is the formula for pH.
yeah,
This is where I got minus 11. Don't fudge it.
yeah,
Minus log. So
yeah.
minus will always come back here and it will come and be raised to the power of minus. That's it. So I actually did it.
Okay, plus
What
or
you do,
minus, yeah. Okay.
I'm even explaining better than you, prodigy. You now, you didn't want to explain from beginning now. So I explained where the minus 11 came from. That's what I mean. The thing is minus log. You know when we have minus anything before log, it will be raised to the power of that thing behind the log. That's logic. That's the logic
Yeah,
there.
sure.
So it's appearing somehow. So, but this is the answer. We're using, okay, let's follow what Prodigy said now. 10 raised to power minus 14 plus 11. I think you guys will get it better that way. So it's going to give you 10 raised to power minus 3. And it's the same as 1 times 10 raised to power minus 3. It is 1 because it is just a mole. They didn't give us maybe 2 moles or something. So I believe you guys should understand it that way. Because we still have many things to do. We even have important things to solve. To be wasting our time on pH. And this is the answer. So maybe you have it in the short statement. What's that? Are we to write the answers with all the signs as in the past question? I don't know. We are going to get a guidance on that before the exam period. We are going to get some guidance and send it to the group. We'll work on it and send it to the group.
Yeah, I think that's fine. Yeah.
They are all questions, so none of us have the idea before. So they said an acid has a pH of 4.5. What is the hydrogen ion concentration? An acid has a pH of 4.5. What is the Ka value? The Ka. So that's what it means. What is the pH value? So maybe I said it another person to solve this for us. Is there another person to come and do it? Any other person that will do this one for us now? No one. Mistakenly muted. Anyone to come and do this for us now? We have the pH to be 4.5. What is H itself? 4.5 equals to minus log this. So you are going to do 10 raised to power 4.5. 1 divided by 10 raised to power 4.5. That's what will give us the answer. I want someone to do it. Miss Aminat, kindly solve it in your book. We want to see you. Oh, yeah. I just raise hand. Do it now. I think I solved this one before. You raised your hand. Are you going to do it or not?
Please, my network is good. Please, can you come again with the question?
Okay. That's why you raised your hand. An acid has a
Like, I didn't
pH
hear
of.
the question. I didn't hear you.
I've you. I've you say, I don't tell that. I don't get married.
Well,
Change your book.
was okay. Oh yeah.
An acid has a pKa, that is just pH of. We'll talk on this later, Andrew. Of 4.5. What is the Ka value? That is what is the hydrogen ion concentration? Yes, thank you for writing it out, Mr. Bright, Mr. Samuel. Thank you for writing it out. That's the question. Check it in the chat. Are you solving it for us? Miss Aminat, are you going to solve it for us? Are you solving it for us? And asking.
I'm not that. Let me try.
Okay. Make it snappy then. Okay. waiting. We are waiting. I think I'll also solve my own here too. So we should get the same answer. Minus log hydrogen Yeah, I'm done. I only need someone that's with calculator to help me. So, but finish yours first. We must get the same answer. I don't know if some people are also trying it. This is what you are using, the formula you are using. Let me try to give them this is the formula you are using. pH equals to minus log hydrogen ion concentration. So it means pKa. pKa equals to minus log Ka. This is what we mean here. You are given the pKa. So pKa equals to minus log Ka. So to get Ka now, you are going to use the law of logarithm. So I'm expecting Ms. Amina to get something. So I haven't done my last calculation. I have 10 raised to power minus 4.5. So anything I get here is my answer. It'll be my hydrogen ion concentration. Abi, there is someone that will help me to do that. 10 raised to power minus 4.5. Anyone with calculator? I'm always not with calculator. Smart. 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 Smart.
10 raised to power minus 4.5 is 3.16 times 10 raised to power minus 5.
3.16 times 10 raised to power
minus 5.
Mole per dm3. So this is the hydrogen ion concentration for me. This is the hydrogen ion concentration. Let's wait for her. You see her value. Three missed calls.
I got 3.2 times 10 raised to power minus 5.
Perfect. You approximated. Thank you. So 16 is approximated to 2 by her. So I have 3.16 in my own place. She has 3.2 times 10 raised to power minus is it minus 5 I wrote? Minus 5 moles per dm cube. You must always write your unit. Yes, it is the concentration. So please, you guys should note that we have to write our unit. Again, this is what is being done. You are given the pH and you are asked to look for the hydrogen ion concentration. So pH or pKa, Ka is just the constant of concentration. pH equals to minus log hydrogen ion concentration. That is the rule. When they say define pH, they'll say pH is the negative logarithm of the hydrogen ion concentration. That's how we define pH. So now the pH is given to be 4.5 equals minus log hydrogen ion concentration to base 10. You know anything, if they did not write the base, it just absolutely means base 10. So I'm going to change this thing, remove it from logarithm form and make it to be in indices form. So before doing that, I know that the coefficient of log hydrogen ion concentration is minus. This minus is going to come to this place, and this will be H plus raised to power minus 1. So that's 1 over H plus. So to change this one to indices now, that will be 10 raised to power 4.5 equals to 1 over H plus. So 1 over H plus, that is 1 over hydrogen ion concentration, hydrogen ion rather, equals 4.5. Because of these two brackets we have, this parenthesis, that's what is making it concentration. So hydrogen ion concentration now equals 10 raised to power minus 4.5. I cross multiplied. This one was the denominator before. Now it became a numerator. And the 10 raised to power 4.5 became the denominator now. So by doing the math here, I got my answer. We got 3.16 times 10 raised to power minus 5 moles per per dm cube, or molar. That is the value for this one. This is how to calculate the pH. Mr. Olaiton, speak out, please.
Hello, please. How did you get the 3.616? Because I lost somehow.
Someone calculated it for me now. I think Miss Joy did. Someone calculated it. I did. I asked that 10 raised to power minus 4.5. This one, 10 raised to power minus 4.5. And she got 3.6 times 10 raised to power minus 5 more per dm. Do you understand?
10 raised to power minus 4.5.
The question is asking. Yeah, exactly. I think that's the question he's asking.
Okay. Sorry, please. Can I speak?
Speak, please.
10 raised to power minus 4.5 give us 3.16, right?
3.16, yes. Times 10 raised to power minus 5.
How do we now get the times 10 raised to power minus 5 dm cube?
It is given there. That's the answer now. 3.16. You cannot get only 3.16. You get 3.16 times 10 raised to power minus 5.
Okay.
Yes.
Thank you.
You're welcome, sir.
Please, I want to ask, how did you know that it is mole per dm cube?
No, it is concentration, molar. If it is like this, you should know that is the rule. There are some rules. So this is the rule. It is moreover, it is concentration. And we know it's about moles. Everything is about mole here. So it is concentration and everything is about moles here. Do you understand?
Okay.
Okay, Prodigy, you were saying something. Speak out, Prodigy, please.
Don't worry, I'm trying to explain what the question that guy is asking, but he has gotten it. Don't worry.
But maybe he is saying another question in the thing. Okay, that's that as per this. Is this answer in the OBJ in the options 3.2 or 3.16? I'm saying it's to minus 1. Is it in the options? 3.2. It not put times 10 to the minus 5.
It's 3.2 times 10 raised to power minus 5.
It's 3.2.
Yeah, they approximated it. You know me, I said I don't have the options with me here. So I don't know how where they approximated it to. So the next one is...
Hello, it's not 3.2. The answer is actually correct. I just calculated it now. 10 raised to power minus 4.5 is to give us 3.16 and some numbers.
Yes,
so we now approximate it. Then we pick the last...
Mr. Man, they approximated it.
They approximated it, Mr. Light. Don't
yes,
worry,
I'm not disputing it.
They approximated it. My man is taking it personal. Okay, now let's keep moving. We have this one is still under pH2. We have, I think another person apart from Ms. Amina will do this. Calculate an acid HA has a pKa of 4.5. That is pH of 4.5. What is the concentration of hydrogen 3 plus? Hydrogen 3 plus in 0.11 mole per dm cube solution of the acid. Anyone with this? Let's give it a try. Everyone, let's give it a try. Which brings a beautiful question for filling the blank of this. Leave it in 3 significant figures. Yeah, I think, Mr. K, I think this question you are asked, I think these people, they are giving them the option. So I think I'm just the one that don't have the option with me. Prodigy and the likes have the option now. You understand? So they have the options with them. There is no options. Now write my 3.16. So they will not miss it for me. I will cost them. Because there is no rule that says leave it in 2 decimal places. Leave it in 1 decimal place. There's no rule.
It is programmed though. They will miss it.
You know something? This is part of the reason we have to be doing past questions. You understand? So the past question was going to help us. Like, this is how the thing was. Instead of solving it again, I'm getting 3.16.
I swear.
So this is part of it. So we just have to keep doing past questions. We should solve past questions. At least that you have high probability. That's another option.
Yeah.
There. So that will help us, Jerry. Okay, the next thing is this. We haven't even gotten to one interesting relation. It is an acid HA has a pH of 4.5. What is the concentration? What is the concentration of hydrogen 3 plus? Hydrogen 3 plus. Okay, could it be okay? It is just hydrogen 3. Look at what I'm going to write. Hydrogen 3 plus, like hydrogen 3 H3PO4, like hydrogen tetraoxophosphate 5. So something like that. This is what they are talking about. 3 hydrogens. This is what they mean in that writing. In 0.110 mole per dm cube solution of the acid. Anyone with the answer?
This one.
Anyone? Is there anyone that's going to give it a try?
I beg you, no first. Make it come, make all my children, let's say, you, the good thing when they do for,
Is there anyone that will give it a try?
You understand?
Is there anyone here? Okay, then, if that's the case, I think I'll have to try it out.
Just look out. Many things.
Let us be kitchen.
Yeah. They go well.
Okay, we have this thing now that an acid has the pH of 4.5. So the pH equals 4.5. I haven't written anything. I'm not using the camera, so I haven't written anything. pH is 4.5. I haven't written anything. Don't worry. What's the concentration of H3 plus in 0.11 moles of the acid? So I'm trying to figure out how I'll solve it. So this is it. We have the pH is given to be 4.5 and it is H3 plus. So what is that thing in this concentration of the acid? What is the concentration of this in that solution of the acid? So now I have my pH equals minus log hydrogen ion concentration. I have 3 moles of hydrogen this time around. So I'm trying to figure out a way to give it out. Let's see. I have my pH already. So 4.5 equals minus log. No, the hydrogen ion concentration will not be easy as this because we are given the thing there. We are given that in already. We are given the 0.11 molar. Is there anyone with an option here? While I keep thinking about my own way, I'll surely get a way to do it. Anyone with an option, please? Anyone with maybe a person that's going to try it in his or her hand too? A person that's going to try it in his or her hand too. Everyone is so silent. Abdullah.
Sir, can somebody tell them that we don't like that pH questions? Can somebody tell them that we don't like that?
Chemistry, they make people silent now. That pH is something else, I swear.
Seriously, yeah. But it shouldn't be a problem. Though. It shouldn't be a problem. We have to just take a good look at it. An acid has this. What is the concentration of hydrogen? This. Okay. It is 3. So could it be after that thing? So let's see. Chemistry will humble everybody now. Maybe so. So in this equation now, if we say the 0.11 moles per dm cube equation, we have 4.5 as the pH. It 4.5 equals minus.
Are you running away? Are you running away? Why is she taking you? I don't understand.
So me, I want to ask, what formula are we using to solve this? Because I think that is different from the first one that we solved.
The same rule. But the issue we have at hand now is that one of them is one of them
I
is
can't hear
getting.
you well, oh, you are far away from your mic.
I think the issue we have now is that we are having the molar percentage that is 0.111. It's because of that 0.111. So, but it will be settled. It will we never reach 2 hours. So, started around 9 for 8 something. Started around 8:40 something. Shall we leave the question first? I will do it after this class and send it to that group. Do you guys agree?
Yes, yes, let's proceed, darling.
Yeah, no wahala.
Trust me. I'll do it and send it to the group. Okay. I'll send it to the group after the group. Number 18. I have it as pH of 4.5. Who is this? We are in number 20. Mr. Petros, please. Mute the
Yes,
mic,
sir.
please.
Sorry. Okay, sir.
Please, thank you.
Thank you.
An acid HA. Thank you now. An acid. Okay. Calculate the hydrogen ion concentration of an aqueous solution with hydroxyl ion concentration of this one. And this one is very simple. This one is even very simple. People will do this one now. I'm going to jump it too. I'll do the both of them and send. This one is simple. When two or more, I don't want us to solve pH again. Maybe I'll explain it with a video and send into the group. When two or more elements combine chemically in fixed proportion by mass, that is formed. Who is going to tell us the answer? What is formed?
A compound.
This law is what? Okay. 22. A mixture in which the components are evenly distributed and the composition is uniform throughout the mixture is called, when they say something is uniform. Miss Juliet, you were raising your hand before you answered the question. Miss Juliet.
Sorry, again.
Homogeneous.
Mr. Olabi has actually answered it. A mixture in which the components are evenly distributed and the composition is uniform throughout the mixture is called that mixture. What mixture?
Homogeneous.
Thank you. It is homogeneous because it is uniform. The one that is not uniform, what is it called? Miss Juliet.
Heterogeneous.
Heterogeneous.
Yeah, good. You're good. You're good to go with. Okay, 23. The solution of sodium chloride in water results in what type of mixture? It's a solution. So what type of mixture is that?
Homogeneous.
You, I'm going to sack you. I said, raise your hand. You shall want me to hear your voice. I told you I'm married already. Don't disturb me. Okay. The next thing is going to be convert. I'm married. Stop disturbing me in the group. When that should I tell you? The types of mixtures are, so I need someone that's different from Miss Juliet and Miss Aminat. According to the two mixtures given now, they mentioned one, they mentioned another one. So Miss Joy, what could be the types of mixtures we have now? What and what?
Homogeneous and heterogeneous.
It's as simple as that. Homogeneous and heterogeneous. Homogeneous is when the components are uniform, while heterogeneous is when they are not uniform. So we have the next question, number 25. Convert 2 moles of caustic soda to grams of caustic soda. That means you are calculating the mass in gram. You have the amount in moles. You are going to calculate the amount in grams. I gave a formula right from the start. I think the first question, that the number of mole equals to mass over molar mass. Please, I won't be solving this. People should do this. Do it rather. I'm expecting the answer. I think you should get it.
It will be molar mass of 40 grams times 2 moles. That's 80 grams.
Please, did everyone understand that? Anyone that doesn't understand that should quickly speak out now before we leave that question. I don't understand. Quickly speak out, please.
I don't understand. Oh. I
Okay.
beg.
I
I
don't
don't understand.
understand anything, please.
Who talk? It's a way if you don't understand anything. No nice. Okay. I'm going to write it out now. These are the parameters given. We have the convert to moles. That means the number of mole m equals to 2 moles. And the gram, convert it to gram. So m, that is the mass, equals to what? I'm already explaining, Mr. Salam. And the molar mass is what we all know. That is by adding the thing. This is NaOH. The molar mass is going to be Na is 23 plus oxygen is 16 plus hydrogen is 1. That is going to give us 40 grams per mole. So number of mole equals to molar mass times mass. Molar mass over mass. Number of mole equals to mass over molar mass. Sorry, Jerry. So mass over molar mass is mass that we are looking for. Mass is going to be number of mole, that's by cross multiplying. Number of mole times molar mass. So what's the number of mole given? 2. So 2 times, what is the molar mass? 40. That is going to be 80 grams. That's going to be 80 grams. 80 grams. Okay. The next question is the molar mass of Na2CO3. That is Na2CO3, washing soda. This man, Mr. K, absolutely right. This man. Okay. The molar mass of Na2CO3. Everyone should try it by themselves. So Na2CO3. Let me give you the expo.
Sodium, should I talk?
Okay, the molar mass. Want to give me the name.
I want to calculate it out.
We are calculating it.
Sodium is 23. 23 times 2
Okay.
plus
That's for
carbon, which is 12,
plus
plus
12.
oxygen 16. 16 times 3.
Great.
So we have 23 times 2 plus 12
46,
plus
58,
16 times 3. That is
58,
106 grams.
106, 106 grams. So that is
Gram per mole.
if you want to get your math, you must put your units there. Gram per mole is the unit of mass.
Yeah, thank you.
Okay, the next one is when propane, we all know propane is a family of alkane. You know, put per mole for the answer. Hi. God. What be this now? Hi. She know be say now. It's only grams they put. You put only gram for molar mass. They are crazy.
But we have taken notes just as you have said. In case we see per mole, per mole, or if we do not see.
Jesus, sorry, you know why I'm even scared? Like,
But is
they
this our
might have
past
even,
question really?
that's it. They might have even put per mole self in the new one. So if we are even following this one now, what's the assurance that
I think these people, from what I noticed, I don't think they have time to update their system. They just
I swear.
shoot questions often. So, I've even noticed it from TME. A lot of their textbook examples are stupid questions with stupid answers, and that's what they will give you as question. Now, if you solve the correct answer, you will fail it. Is that the course material that you must use?
Yes.
Hey, it is well.
It is well. Okay, the next one is when propane reacts with oxygen, dash and dash are produced. C. Alkane is the family. So when alkane reacts with oxygen, so we are going to get something. That is combustion of alkane. So that is just this, right? The formula. Alkane is CXHY, but propane now is going to be C3H8, right? So plus oxygen gas is going to give me CO2 plus H2O. That is carbon dioxide and water are gotten. So you can balance your own equation by yourself. I don't have time for that now. Carbon dioxide and water. Thank you. Carbon dioxide and water. So the same thing. Oh yeah, which one did they now choose in the material, Mr. Samuel? Is it carbon dioxide they wrote or carbon dioxide? You want to see how
Carbon dioxide and water.
they have smoke Igbo. So if I write carbon dioxide now, they'll miss it for me. They have smoke Igbo. Okay.
Please, I want to ask something.
There's no and it was carbon dioxide, comma, then water.
What's the difference between
I did it I wrote carbon dioxide and
God.
water, and
There's difference, so
in more
there's difference, so just use that comma.
Please, there's space between carbon dioxide and
God.
This thing is getting out of hand.
And or full stop.
Please, I want to ask question.
Even the carbon dioxide, there's space. Carbon and oil dioxide, there's space in between.
It's true. It's true. You have to write carbon, give space, and put dioxide, then cover, and put water.
Please.
Then remember to put full stop. Full stop.
Space, right? There is no space between carbon dioxide, right?
Sure, now
Because
there's no
material, there is space. And
There can still be space now.
Because in that course material, I saw it that there is but since you guys are saying there is no space, that means I'm sorry then.
I beg, we will continue our stuff, Jerry. I think we are getting close to somewhere.
Please, has anyone come across logarithm in our course material? Like the course material I downloaded from the website.
Is it chemistry?
Yes, both of them, both inorganic and practical.
No.
Not at all. I think the practical chemistry talks about pH a little bit. That's where logarithm occurs. Usually occurs for chemistry, practical chemistry.
Okay.
The smallest unit, okay, we are number 27, number 28. Convert 500 grams of Na2 to moles. Everyone can do this one now. So mole equals to mass over molar mass. We have the mass to be 500 and molar mass is equal to 106 by calculation. So Mr. K got 4.717 mole. So that is the answer. Convert it to mole. So number of mole equals to mass over molar mass. So what is the mass? 500 grams over what is the molar mass? Na2 that is the molar mass is going to be 106. So 106 grams per mole. So you do your math there, you are going to get 4.7. What did you get now? 4.717.
But yeah, that's another. So this one now, sorry. So if we approximate this now, is another issue.
No talk that again.
Yes, the issue. It's in our computer they mark the thing. So is the answer.
Seriously. Hey, what's the assurance that this is the answer? You don't get to our question. What's the assurance that this is the answer? What's even the assurance that this is the question that we even come?
Are you crazy? Must we write?
I think these people actually repeat questions from what I see. Because there are some questions I'm seeing here now that I've seen in another past question before.
If they really do.
Yes, they really do.
Because everything they set is from the course material. I'm even sure it might not even be the teacher that is setting the question. It might just be somebody that will just pick it up randomly and use AI to set it and then place it online.
Somewhere is okay. Somewhere don't do. Please, you don't.
Let's continue. Number 29. A compound in grams is converted to mole by dividing it by. This is the formula we've been using since. A compound in grams is converted to moles by dividing it by what? Molar mass.
Molar mass, yeah.
Or formula mass. We call it formula mass too. Don't carry that hypertension stuff.
Don't let them write formula mass again. Which one are you doing again? Don't let them write formula mass again. No.
And it's formula mass that is in the course material. Formula mass and molar.
Joy Ali, please. Which one is this one again?
Formula mass.
I mean, molar mass, I know.
Oh yeah.
Exactly.
Now don't worry. Now we settle your quarrel. Now
Let's
we have
give
to settle. Now we settle your dispute. Don't worry. You
let's
choose
give
formula. You choose bola. No problem. Okay. Oh.
number 21. A mixture in which the components are not evenly distributed and the composition is not uniform is called. Everyone, let's write this out by ourselves. We all know what this one is. They are not evenly distributed and the composition is not uniform. So we all know what the answer is going to be, right?
Yes, sir.
Heterogeneous. So that's it. So number 30, I jumped number 30. The smallest unit of the compound that can manifest all the chemical properties of the compound is called. The smallest unit of a compound that can manifest all the chemical properties of that compound is called a molecule. Don't choose atom. It is a molecule. Atom is the smallest unit of a substance or unit of a compound. But molecule is the smallest unit of a compound.
Compound,
So
yeah.
let's meet that. Number 32. Mixtures with particle sizes between 2 to 1,000 nanometers. They are called what? Anyone? They are called colloids. Colloids. Is it colloid I will be choosing now? We call them some micro stuffs too. But colloid is right. Colloids there. Which one is this one? Are you on colloids? Mr.
Who wrote that? Who is that? Go and write colos for now. Don't worry. Now you go there on that colos. You write colos. Now you go be on that colos. Don't worry.
Okay. So now mixtures with particle sizes between 2 to 1,000 nanometers are called colloids. And so now, number 33. This is where we are going to calculate another thing again. The label, number 33, the label on a stock bottle of acid reads 56% by mass. They are given the percentage by mass. So you should be writing them somewhere now. 56% by mass. That's the percentage by mass. Equals to 56%. Specific gravity of 1.25. If the molar mass of the acid is 56 grams per mole, what is the concentration in grams per dm cube? What is grams per dm cube of the acid? The concentration in grams per dm cube. So I have my parameters given this way. The percentage by mass is 56%. The specific gravity is 1.2 grams per cm cube, 1.25 grams per cm cube. Molar mass is 56 grams per mole. So what is the mass in grams per dm cube? So to move with that now, we know that 1.25 grams is present in 1 cm cube, right? Given to us. They said 1.25 grams per cm cube. So now in 1,000 cm cube, that is 1 cm cube, which is going to be 1,000 times 1.25. That's 1,250. Abi? Yeah, 1,250 is going to be in 1,000 cm cube. If you multiply the both of them by 1,000, multiply 1.25 by 1,000, and multiply 1 cm cube by 1,000, we're going to have 1,250 in 1,000 cm cube. That is 1,250 grams in 1 dm cube. So now, my thing is going to be 1,250 times, what is the percentage given? 56 all over 100. This is what we are going to use now. So who will do the math for us? Is the answer that we get that will be the answer?
700 grams.
Okay, so 700 grams
per
dm cube. So 700 grams per dm cube will be our answer. I come with my explanation again. Battery is running low. My system is almost good.
You are on the same. You are on the same percent.
So
you're not gonna lie.
I I said
You no
1.25.
get light up.
Huh? God, let me keep this thing before you kill this. Okay, I think we are going to stop this thing. So 1.25 grams in 1 cm. That is the specific density, specific gravity given. So share your screen, Kingsmith. So 1,250 will be in 1,000 cm cube. We are going to make it 1 dm cube. So 1,000 cm cube is the same thing as 1 dm cube. That's 1,000 milliliters gives 1 liter. So now 1,250 grams now is going to be 1,250 times the percentage given. That is 56 all over 100. So you can screenshot this thing and use it to solve another question on yourself. Okay, so I'm going to continue now. We still have more questions. 31 questions. Okay. I thought you are not responding. That's why I didn't bother. Okay, I don't plug the phone for system. It's not have a chat system. Smart. Yes. You guys should be done with it. Okay. System don't die. But share your screen. The system don't die. Fine. But 2 a.m. Kingsmate. 8. What's not getting to do? 8 a.m. Wow. That's quite impossible. Let's just get it to number 50. I want us to stop at number 50 or 40. So share your screen. We should continue. We should get it to somewhere before stopping. That number is not fine. 34. Now stop there. Please, share your screen. Okay. Come on. Okay. So what's the next question? Okay. I'm going to scroll by yourself. I cannot scroll your screen for you. Keep going.
No, this is where we are.
Oh, yeah. Scroll it. Okay. We just finished now.
Yeah.
So now, mixtures with particle sizes greater than 1,000 nanometers. Everyone will be saying the answer now. So maybe it will be faster. So mixtures with particle sizes greater than 1,000 nanometers are called suspensions.
Okay.
Seriously, as everyone is in it now. I love it the way that this person will give the answer. Okay, mixture made up of sand and iron filling are known as heterogeneous. So is there anyone here that will tell us the reason? I think that will be okay. The reason, why is it heterogeneous? That mixture, it is heterogeneous. We know why. Anyone?
Because they are not the mixture are not uniform.
They are not uniform.
Like
they are not the same.
Yeah, they are not the same. Yeah.
No, thank you. That's it. Thank you. So the formula for sodium carbonate is what? Prodigy. Be like say you go cover your answers. This thing will not help.
they go see
The formula for sodium carbonate is actually you can just take this thing and come and put one thing there, cover everything. Anyway, you should not be deceiving ourselves. The formula for sodium carbonate, that is Na2CO3, sodium transocarbonate 4, Na2CO3. So the next question is the formula for sodium caustic soda, that is the caustic soda, the strongest base ever. The strongest base ever is known as caustic soda. That is sodium hydroxide. Sodium hydroxide. So that's the formula for caustic soda. It is a very strong base. So in balancing this equation, we have Na2CO3. It's going to give NaOH plus A CaCO something. Which kind of equation is this one? Okay, I know they are right too, but you guys agree with me. This equation is one stupid equation. Is it possible?
NO2CO3.
Giving us NOH plus CaCO3. Is it possible? Law of conservation of matter can neither be close nor destroyed.
I think what they are trying to even say there is that we should find out the number of a substance or number
Yes,
of
we are.
moles in that substance, but they did not complete the question well.
There is still a reactant. It is two reactant that is supposed to be there. They are giving us one reactant. They only wrote They only wrote Na2CO3 instead of them to write Na2CO3 and what could be the next thing? Maybe CaOH2. Maybe Ca open bracket OH2. CaOH2 or
Yes, I think that
H2CO3. Okay. It is H2CO3. H2C. No, C is not H2. It is Ca,
C
John.
A yeah, C A S.
So now this thing is that question mark means what is the number of mole of sodium that is going to react with it? Look at sodium in the right hand side. Sodium is 2 in the reactant side, and it is just 1 in the product side. You just have to put 2 at the front. It will become 2 in the product side too. So you look at the equation, is it balanced? If it is balanced, then 2 will be the right answer.
How come calcium is there?
Eh?
Calcium is there now. CCA.
What I'm saying is that they didn't write the equation completely.
Guys, please,
Definitely,
I'm low. Come back to that question.
NaOH plus CA. So what the question I
please.
want to ask
The
is,
reactant
I
is
think
not
the question
complete.
is NaOH plus
the reactant is not complete. This is what they're
CaCO3.
supposed to be. I'm going to write it out now. C Na2CO3 Na2CO3 plus CaOH2. So this is what they are supposed to write. It's going to give us NaOH plus one is a base reacting with the base. It's just a mixture then plus CaCO3. This is what they are supposed to write. So that's when you now know that your sodium here is 2 and it is 1 here.
Yes,
So you just
yes,
balance it by
that's it.
putting 2 at the front. So this is the equation they are supposed to write. Do you get it? Okay.
Yeah, what's even their own major equation with the way this
This is
thing
their
is?
stupid equation. It's not major equation. You say stupid equation. This is their stupid equation. So the thing they are asking us to look for is this thing. Let's say this 2 that is here is X. They're asking us to look for the value of X. The represented with is the question mark. They not say look for the value. So this we are balancing the equation. 2 is sodium is 2 here. So sodium is supposed to be 2.
Yeah.
So since it balances with all this hydrogen and oxygen, so it's everything right. So forget about they did not give us their product. It's their own problem. It's not our problem. Okay, the next thing, please.
So please, is there any other way to do this? Like seeing the answer makes me not to think. I'll just say out the answer.
No, you cannot deceive yourself. You better concentrate on
how to get it.
I don't know. I wish you the best, Sha. Okay, in a solution, the components in smaller this. So in a solution, I zoomed it and scrolled it to one side. The component in smaller amount is called, everyone knows that. The one that you apply, that the one that is in smaller amount, when there's a base before. So the one in smaller amount is known as the solute. Why the one in bigger amount or larger amount is known as the solvent. So the solute plus the solvent makes up the solution. That's what Nigeria was before, but now solute key. So the second one is in a solution, the component in larger amount is called solvent. It's either water or some gases. So please continue, Mr. Prodigy, Mr. Andrew. Okay. A substance that is made up of two or more substances which are not chemically combined is called, that is gari and rice that are not chemically combined now. The substance is called mixture. Mixture. It is called mixture. So now calculate the percentage by mass of hydrogen in this thing. I'm going to explain this too. Calculate the percentage by mass of hydrogen in this thing. This thing is NH3, ammonia. The percentage by mass of hydrogen in ammonia. Ammonia is NH3. Percentage by mass of hydrogen here is going to be hydrogen. What is the number of hydrogen here? Amount of hydrogen inside this thing over amount of the whole thing multiplied by 100. This is the formula. That's mass of hydrogen over mass of the overall times 100. What is mass of hydrogen? Hydrogen is normally 1. Nitrogen is 40. So I have 1 times this 3 that is there. 1 times 3 over nitrogen is 14 plus hydrogen is 3 times 100. So this is, if I give any problem? Any problem? So 1 times 3 is 3 over 14 plus 3. That's 17.
So
With this one now, you are going to get 17.765%. 17.65%. That's what we are going to get. So they are not multiplying it by 100. That's why they are getting 0.01775.
Yeah, that's what I want to say.
It's because they are not multiplying their own by 100.
Yeah.
They are writing
So what did you get?
0.1765. But to percent 17.6. That's how you are looking for now.
Okay, you said nitrogen is 14, right?
Yes.
Okay.
Nitrogen is 14. So nitrogen will be nitrogen over NH3 times 100. Everyone can try that by themselves. This is the formula you're using. Nitrogen is 14. So that's 14 over 14 plus 1 times 3. That's 14 over 17 times 100. Maybe you get 82. You get
Oh wait, this is not the atomic number we are using, but I think it's 7.
You can never use the atomic number. You are using the mass.
It will be times 2. The reason it will be times 2. Multiply by 2.
Oh, okay.
Oxygen 2 is 8. So that's why it's 16. You multiply it by 2. And the atomic number of oxygen also is 8. But we are talking about the stuff is 16.
But some of them, it is not actually multiplied by 2. It is because the
Yes.
number of neutron and proton are the same. That's why we will have them multiplied by 2. So like copper now, iron, all those ones. Imagine of you will. So thank you. Let's continue, please, Mr. Andrew. I respect you now. Mr. Amina, you are not talking. I don't miss your voice. Where are you?
I've been talking.
Not talking.
Nobody answered me. Nobody reply me. So what did I want me to say again?
We are replying now. We are replying. I'm just trying to let you know.
No, even the calculation that you did, I've done it. Immediately
You
I
are the
saw
one
the
that
question.
silent Amino's voice now.
Andrew, please.
I did not say we are not doing it. What I'm saying is that I don't really miss your voice. And as I'm already missing your voice, so you should try to understand now. So this is a number. This number 0.0055 has how many significant figures? All these zeros now. 1 is before the point, 2 are after the point. And so since they are after the point now, and it's a good number that is ending them. So we have 2 significant figures here. The answer don't dey here, so I think the no go gree think. So 2 significant figures. That's what we have, the 5 and the 5.
Okay.
The amount of product that can be obtained from an experiment is called what? So, there are two types of product. One will be the product that you obtain, and one will be the product you expected to obtain. So, the one you obtain, is the experimental yield, or the actual yield, or the measured yield. So, they are using actual yield. Let's say it's actual yield, you don't know another type, you don't know another name for it. So, the amount of product obtained from an experiment is called the actual yield. That's the actual yield you obtain from the experiment itself. So now, but the theoretical yield, okay, that's the next question. The amount of product expected from given amount of starting materials is called theoretical yield. That's what you calculated before. That's what you've been expecting. So you now get something like this. So that means you've gotten your theoretical yield. That's when you get your theoretical yield as your own stuff. That's when you have high percentage. Okay, in a chemical reaction, the balanced chemical equation, which shows the quantitative relationship between masses of reactants and product, is known as what? You have written the answer. When you have written the answer. The balanced chemical equation, which shows the quantitative relationship between masses and reactants, masses of reactants and products, is known as. Maybe you should just take it as play. They are giving us a stoichiometry of the reaction. Stoichiometry of the reaction. Okay. We keep going, and we say the amount of energy required to break a particular bond. That one is bond energy. Everybody knows that. Amount